Volume maths can be used with a conditional nested formula to colourfill a stratigraphic sequence as seen here in the section view. The formula is a simple if-then-else statement for horizons H1 through to H6. The output is a constant value for each sequence that is displayed as a transparent colour. For more information on constructing this formula, watch parts 1 and 2 of this video series on sequence overlays. This video will create something a little more fancy and introduce pattern fills. There is no pattern fills option in Insight, so we will use a workaround. Instead of assigning a constant to this sequence, it's possible to assign a formula. By modifying the constant variable to something that varies both laterally and vertically, a dipping sequence can be created. There are lots of ways to do this, but a very simple solution is to use the variables provided in the volume maths process, two-way time, milliseconds, and inline or crossline, or x and y. By adding two-way time milliseconds and inline or crossline values together, you can create a value that laterally dips. I will create a new volume maths process and name it dip left. I don't need an input volume for this, but by selecting one, it will populate the output extents to match its dimensions. Volume Maths has a quick help icon that lists all the variables and functions recognised by Insight. The first variable to use here is the two-way time milliseconds or TVDSS meters variable, providing a vertical change. Scrolling down, all the volume trace headers are also available for use. Inline, crossline, X or Y can all be used to provide a lateral change in the sequences. The formula I want is two-way time milliseconds, plus inline, plus crossline. The resulting volume looks a bit grey. This is because I'm using the class from the original Seismic. I need to make a new custom class for my dipping sequence. I will call it dip left. The colour bar banded rainbow blocky is good to show the dipping nature of the new overlay. After assigning the custom class to the overlay volume and setting the volume range, the dipping bands can clearly be seen. To change the colours to patterns, there is a special colour bar that can be applied to the class called banded_pseudocontours10, which has 10 black lines equally spread across an otherwise transparent colour bar. It gives the same result as contouring. To apply my pattern to a specific sequence, I must use the conditional statements from parts 1 and 2 of this video series. The formula uses an if statement to compare the current two-way time in milliseconds to the horizon defined as H1. If less than H1, the output is set as nan, else the output is compared to H2. If less than H2, the output is defined by the formula for dipping values, else if deeper than H2, it is set to nan. Defining H1 and H2 horizon inputs completes the process, and the section view updates to only highlight the sequence from the seafloor to T-carbs. To create another pattern, I will copy the process and name it dip right, and I will change the input horizons to cover a deeper sequence from B-carbs to top res. The only other change required is to subtract the crossline instead of adding it. This will make the sequence bands dip to the right instead of the left. Assign a custom class to the new volume and compute the volume range, and the dip right sequence can be displayed on the section. Adding the new patterns to the coloured sequence group, it's possible to see both colours and patterns overlaid on the stack Seismic. To finish, let's go crazy and introduce a vertical pattern. Using only the inline and crossline variables without two-way time milliseconds will give vertical banding. Likewise, using two-way time milliseconds without inline or crossline will give horizontal banding. To show off another feature of volume maths, this time I will apply user-defined variables. I will create a new volume maths process and call it dip_all. I select an input volume so that the output extents are updated to match. This pattern will cover 3 consecutive sequences, and so I need to add and assign 4 horizons. Opening the process Quick Help, I can check the syntax required for the formula. Insight provides predefined variables and trace headers to include in the formula, 7 of which I have already included. It is also possible to define your own variables. If you're reusing the same variable multiple times, or if you wish to organize your equations, defining your own variables can be very useful and sometimes more efficient. The syntax is variable name equals formula. In this case, dip_l, short for dip left, equals 2a time underscore milliseconds plus inline plus crossline. Very important is to finish a variable definition with a semicolon. Similarly, I can define dip_r for dip right with a minus instead of a plus crossline. And my new variable is dip_v, dip vertical, which is defined as 3 times crossline. Multiplying by 3 makes the output volume range similar to the dip_l and dip_r variables. All equals variables are ended with a semicolon. When using user-defined variables, the formula must also begin with an output variable that is equal to the formula. Here my output variable is represented by OP, short for output. The process output can be set to any of the input variables or the formula. I will select just the formula output, OP. The volume must be assigned a custom class and have the range adjusted. The range can be manually adjusted if the automatic range isn't quite right. Grouping the volume with other sequences we have created gives flexibility in mixing and matching the sequences. Individual group components can be turned on and off to change the final composite view. With careful formula construction, the line patterns can be adjusted in density and gradient. It's even possible to introduce wavy lines or lines parallel to the horizons. Here's another complex pattern that I made earlier. I have now created complex sequence highlights for use in interpretation or presentation. These formulas are just ideas to get you started, but the building block nature of volume maths means that you can create your own designs in addition to what I've just shown you.
If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.